We have the linear factorization theorem and the complex conjugate theorem. Let's start from here. Suppose we have a polynomial of degree n equal to a1 xn plus a2 xn minus 1 plus and so on plus an xn minus n. As we can see, the degree of this polynomial is n, so degree equal to n. So the linear factorization theorem is saying that whenever the degree equal to a certain number, the factors must be equal to that number. That means we must have n factors for this polynomial. Okay, for simplicity, suppose we have a polynomial of degree 3, which implies that we must have how many factors? 3 factors. So we could have s equal to a, for example, then s could also be equal to b, s could also be equal to c. So this a, b, and c could be either real or complex numbers. In the same vein, the linear factorization theorem is telling us that if x equal to a, we can have s minus a equal to 0, right? Then if x equal to b, we can have x minus b equal to 0. Then if s equal to c, we can also have x minus c equal to 0. So this implies that this here are the factors of this polynomial, and these are referred to as the zeros of the polynomial. And the complex conjugate theorem is saying that suppose we have x equal to a as one of the factors of this polynomial, as we rightly said here, then such that a itself equal to m plus ni, which implies that a itself is a complex factor. Then this theorem is saying that for as many times as we have a complex factor as one of the factors of the polynomials here, then we must always have the conjugate of such factor as one of the factors of the same polynomial, which implies that if this is a factor, then we must have another factor which looks like this, which is the conjugate of the complex factor. Thank you very much.